Okay, so what we're going to look at now is a pre-paper question. This was the Leaving Cert Ordinary Level pre-paper question from Examcraft in 2019, and it was question 8. Okay, so it says, Bright Light Limited manufactures light bulbs. The lifespan of the bulbs is normally distributed. The lifespan in hours of a random sample of 20 bulbs was tested, and the following data was recorded. So this was the amount of hours that each light bulb lasted out of those 20 bulbs. Calculate the mean lifespan for a bulb in this sample. Okay. Now that's the first part of that question, but if you just have a look at the second part, it asks you for the standard deviation. Okay. So because it's asking for the mean and it's asking for the standard deviation, I'd advise you there to save time and just put them all into the calculator as one. So what we're going to do is we're going to just turn on the calculator there. So just turn the calculator on. And we need to go to menu. And we go across there to the second option, which is statistics. Okay. Then it asks us a load of options. The first variable there is the one that we're using. So one variable, so we press 1. And it asks us to input the information. So what we need to input there is we need to input all of the information that's given. So let's start with the 11,400. And if we put in the 11,400, press equals, and we'll do the second one there. So we'll work down and we'll say 12,555. So 12,550, I should say. Then we have our 11,700. Then we have our 11,650. Okay, so now we're on to the fifth one, which is 13,900. Then we're on to 12,100. Then we're on to 9,900. We're back on to 11,900 next. Then we're on to 14,000. Then we're on to 11,450. Then we're on to 12,200. Next after that comes 10,000. After that comes 12,350. After that comes 12,600. After that comes 12,300. So you can see there we have 16 pieces of information put in now. So we're back up to the top of the last column, which is 13,100, 11,800, 10,100, and finally 11,900. Okay, once you've put in all that information, which we've just done there, and we can see there that makes up 20. Have I missed one? Let me just go back and double check. So I have 19, so 4, 8, 12, 16, 20. There should be 20, so I'm just going to go back and double check. So the very first one, 11,400. Then the second one, 2,005, 11,700, 11,650. Then 1,390, yeah, 1,200, 100, 1,300. Okay, so I was missing the 1,300, so I put that down at the end, right? So 13100 equals. So you can see now we have our 20 pieces of information put in. The fact that we have them all in there, now we just need the calculator to calculate them. So what we'll press is we'll go to options and we'll go to one variable calculation, so that's option 3. And that gives you everything there. So that gives you your mean. You can see your mean there of 12,000. It also gives you your standard deviation, okay, which we can see there. So by doing this and putting all that into the calculator, it works out those two values. So that's question A, part 1 and 2. We've got our answer there. Okay. So what I'd do if I was you was I would fill this in. And I'd start off by just explaining what the mean is, so that the examiner knows that you understand what you're doing. So the mean is equal to the sum of the inputs divided by the number of inputs. So in this case, we worked it out to be 12,000. So from the workings that we did in the calculator, we can also put in what our standard deviation was, and our standard deviation was sigma. Typically we write standard deviation as sigma. So sigma is equal to, and we got an answer there of 1093.389226. Now they want that to the nearest whole number. So that was 1093, because if we were to round that off, that 3 will cause that to round off. So that represents the number of hours. So, based on the free paper, so far in that question, you would have got 10 and 10, you would have got 20 marks. So 10 marks for part 1. And 10 marks for part 2. All from just doing simple calculator work. So part 3. Part 3 says, what percentage of the bulbs do you expect to last between 10,907 and 13,093 hours? Explain your answer. So this is what we do. This is, we calculated what the standard deviation was, we calculated what the mean was, and now we're being asked to use those figures to see what the distribution is. So if we have a bell curve, we'll say, so you can see there we have a bell curve. We know that the standard deviation, we know that the mean is going to be 12,000. So we're going to put in 12,000. If we go back one standard deviation, we'll have 12,000 minus the standard deviation that we just calculated to be 1,093. That will leave us with 10,907. So that would be here, 10,907. Okay. If we went forward, we'd have 12,000 plus one standard deviation, which is 13,093. Okay. We can see there in the question that they're asking us how much of the data will be expected to last between, how much of the results we expect to last between 10,907 and 13,093. And we can see that that's just within one standard deviation of the mean. So this here is 13,907. I should put that over further, sorry. 13,907. Okay. So we're looking at all the data that falls in here. Okay. And we know from the empirical rule that that represents 68% of the data, right? So in ordinary level, we just rounded off to 68. This is from a higher level text. So this represents 68% of the data. So we need to fill in here that 68% of the data falls within one standard deviation of the mean. So that just means that 68% of the data falls either side of the mean. So you've got one standard deviation this way and one standard deviation this way, and 68% of the data falls in that bracket. And that there was worth 5 marks on the pre-paper. Okay. The next part of this question. So another company, Solace Bulbs Limited, claim that 85% of their customers prefer their bulb to Bright Light Limited. An independent research company was hired to test the company's claim. They decided to survey a random sample of 500 customers. State 2 methods that the research company could use to carry out the survey. So, obviously there's loads of different ways you could conduct that survey. They could do online surveys, they could do telephone calls, they could do customer feedback. So there's loads of different ways they could do it. So we're just going to squeeze in two there. So we'll just do online survey. We'll put down telephone calls. And we'll put down one more. We'll put down, and we'll put in interviews. So whichever way you, whichever one you want there. And again, that was 5 marks. Okay. For one of your chosen methods, state one advantage and one disadvantage of the sampling method. Okay. So that's the second part of that question. So I wanted one advantage and one disadvantage. So just pick the easiest one that's easiest to analyse. And in this case, the one that I'm going to pick is going to be the online surveys. Okay. So the advantages there is that they're cheap. Okay. Easy to distribute. Okay. Disadvantage would be that there is a limited sample available due to IT. So not everyone will be able to complete the online surveys, what that means. So limited sample available. So that's need access to IT. Okay, and that there is worth a further 5 marks. Again, do keep in mind this is a pre-paper question, so it's very open in the question there, right? So we're going to move on there and we'll do the next part, which is back to the kind of stuff that we typically see in the exam, that being the margin of error. Okay, so we can see that we're asked to calculate the margin of error. So the margin of error is being asked and correct 2 or 3 decimal places. Okay, so among the sample customers, 398 agreed that Solus Bulbs Limited lasted longer. Okay, calculate the margin of error in the sample, correct 3 decimal places. Okay, so what we're doing there is we're going back. The sample that we were looking at was out of 500 customers. Okay, so out of 500 customers. So I want to get the sample proportion. So, like we know with the margin of error, the margin of error is always equal to 1 all over the square root of n. And that's where n is the sample size. Okay. So in this case, they want us to get among the sample customers that much, then calculate the margin of error. So the sample size was actually back. So it's nothing to do with the amount of people that agreed. So it's nothing to do with this. It's to do with the actual sample, the number of people that were sampled, right? So n is the sample size. And the sample size, we know from earlier in the question, is 500. So it's going to be 1 all over the square root of 500. Okay. And that will give us a decimal, which is 0.0447135. Okay, they asked us to give that correct 3 decimal places. So they wanted as a decimal correct 3 decimal places. So go back 1, 2, and 3. look at the number that follows, which in this case is a 7. So that will cause that to round up. So we'll end up with an answer of 0.045. Okay. And again, that year, that was allocated 5 marks. Okay. So in that pre-paper, that was 5 marks if we got the margin of error. So you can see there every year, more or less, when you're asked to get the margin of error, it tends to be worth 5 marks. Okay, so part 4. Carry out an appropriate hypothesis test at a 95% confidence level. State your null hypothesis, alternative hypothesis, and your conclusion clearly. Okay, so the null hypothesis is obviously the claim that we have. So the claim came there, and the claim was in part B of that question. It said it in the very start of this question. So it said that another company, Solus Limited, claims that 85% of their customers prefer their bulbs to Bright Limited. Okay, so the claim there, or the null hypothesis, is that 85% prefer their bulbs. Okay, so 85% of their customers prefer their bulbs, prefer Solus's bulbs. Okay, so that's the claim. The claim is that 85% of the customers prefer Solus's bulbs, right? Solus's bulbs, limited bulbs. Okay, so the alternative hypothesis is that the number of people, or the percentage of people, we'll say, the percentage of their customers, I suppose, that prefer SOLAS bulbs limited bulbs is not equal to 85%. Okay, so let's just look at that again. So what you do is you take your null hypothesis, and that's just the claim that they gave. So they made that claim. They made the claim that 85% of their customers prefer Solus's bulbs. The alternative hypothesis is always just, it's the opposite of this claim, right? So instead of saying that they prefer them, it's saying that they do not prefer them, okay? So you're still using your 85%, but it's just saying that they do not, okay? So that is that one, right? So in order to be able to prove this, what we need to do is we need to be able to get a 95% confidence interval level, okay? And how we do that, okay, it seems to be more structured than other questions that we've done. How we do that is we get our sample proportion, and what we do with that sample proportion is we find our confidence interval. So we subtract the margin of error to get our lower limit, and we add the margin of error to get our higher limit, and that tells us the limit within what this has to fall, and we'll see then if 85 falls inside that limit or outside that limit. Okay, so first thing we need to do is get our sample proportion, right? So our sample proportion is going to be the first thing we need to get. So in order to find out what the sample proportion is going to be, we need to go back over that question, and we can see here that the amount of people that said they prefer Solus's bulbs was 398 out of the sample of 500. So we need to form a fraction with that. Okay, so 398 out of 500. So that's our sample proportion. So p hat, which is our sample proportion, p hat will be equal to 398 out of 500. Okay. And now to create those confidence intervals, what I need to do is I need to subtract p hat minus the margin of error. So subtract 1 over the square root of n to get our lower limit. And that's going to be 398 over 500. And we need to subtract the margin of error. And we know from the last part of that question, the margin of error is equal to 0.045. So subtract 0.045. And that there will equal 0.751. So we now have our lower limit. What we need to find next is the upper limit. So the upper limit there is going to be the exact same thing, except for instead of subtracting, I'm going to add them, right? So instead of subtracting, I'm going to add. So p hat plus 1 over the square root of n. Okay, so that's going to be the exact same 398 over 500. And instead of subtracting, I'm adding to find the upper limit. And if I add that there, I should get an answer of 0.841. 0.841. Okay. Now, the thing to remember here is that that's going to be the start of our confidence interval. So that's going to tell us the parameters, I suppose, for our confidence intervals. So what we'll do there is we'll just look at that and we'll set it up. So we're looking at everything between 75.1% is going to be less than or equal to x, which is going to be less than or equal to 84.1. Okay, now we know that the claim was that 85% of people, but we know that 85% falls outside of this. So if 85 falls outside of that, then we cannot accept the null hypothesis. Okay, so the conclusion there is that we cannot accept the null hypothesis because 85 falls outside the 95% confidence interval. So conclusion. As 85% falls outside the 95%, we can say CI because that stands for confidence interval. As 85% falls outside the 95% confidence interval, we cannot accept the null hypothesis. Okay. Just a quick point to make there is that sometimes people say that we reject the hypothesis. We tend not to say reject because if we reject it, this here is based on averages. So this is based on averages. So this isn't 100% correct. So if you were to sample all of the customers, technically speaking, there might be 85% of them. Okay, so there could be 85% of them, but the data would strongly suggest that it falls outside it. So that's why we say we cannot accept, okay, as opposed to saying we reject. Okay, so typically instead of saying fail, you should be saying that we cannot accept. Okay, and that there was also worth 15 marks. Now, another quick point to make is this was a pre-paper question, and generally speaking, when they ask this question, they do structure it so that they get you to get the margin of error, then get the hypothesis test, and then get the confidence intervals, and then do a hypothesis test. So normally in an actual exam, it is more structured, whereas here they kind of got you to do everything at once. Okay, so typically they break this up into two parts where they get you to get the confidence interval as a separate part and then get you to do your hypothesis test as a separate part, and they're typically worth 5 and 10 marks, right? So here they just bundle it all together.